Okay, this is problem 20 of chapter 17. So if you've read over the problem, you'll see that these biologists are investigating or doing research on frogs, and they think there's some genetic trait that's associated with toxins, their frog sensitivity to toxins in the environment. So they did some research, and they believe that there's a fixed probability of frogs having this trait. It's 1 out of 8, and they're sort of suggesting that it hasn't changed. So we're going to treat it as it's fixed. Okay, and then it looks like they've collected 12 frogs. So the sample size is 12. Okay, so when you look at these problems, you can kind of see that they're asking questions about sort of like X successes in N trials. So it sounds like binomial. Okay, a binomial model would work. So, but before we dive into a binomial model, we need to check the conditions. So first, we have success-failure condition seems to be satisfied because either they have the trait, right? They have the trait, or they don't. Okay, so that condition seems to be satisfied. Now let's see, what's the other one? They have that, and then we want independence. Oh, and the other one was a fixed probability, and we already established that. That's why I couldn't remember. A fixed probability for each event. So that's taken care of. So the question is, what about independence? Are the events independent? So I don't know. I'm trying to think through this, and I'm not too sure. It depends on. They didn't give us a lot of information. If they sampled from, say, all over the state or something like that, then probably so. But if they sampled the frogs in some kind of local area, then probably not. So how can we deal with independence? Well, the way we do that when it's not clear is we could say let's look at 12, a sample size of 12. So 12 frogs is clearly is less than 10% of the all the population of frogs. So that means that the 10% rule is satisfied. Okay, so that helps us satisfy the independence condition. Okay, so now we can move forward with a binomial model. So before we start doing the probability calculations, I just want to show you sort of like the picture that I keep in my head. I've seen different kinds of pictures. If you go out to the Khan Academy videos, he has some interesting pictures, and he draws things a little bit differently, kind of like a histogram. But here I'm going to draw it the way we've been drawing discrete probability models, like this. So, okay, so we're going to go from like 0. There could be 0 frogs out of 12 that have the trait, or there could be 12 out of 12 that have the trait. Okay, so the model, the table would look like this. And I'm going to just, I think we only need to go out to about 5. And so this would be 11, 10, And then let's just do dot, 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 because we don't need to fill this in. Now if you wanted to fill all these in, you could use the function binom PDF, and you could put, I think you put in the probability. So this would be 12, and you could just put in 1/8, and it would give you all these probabilities, okay, which might be useful. Okay, so let's look at the first problem. They're asking us, what's the probability that x equals 0, that none of the 12 have this? Well, that's going to be binom PDF, because we just want this probability right here. So that's going to be, we'll use n, p, and x. Okay, so I'm just trying to give you the theoretical right now. So binom PDF of 12 and 1/8, and x would be 0. Okay, and if you do that, I'll have to do it real quick. I think it's 0.20, something like that. So hang on. Sorry about that. So I get 12, 1 divided by 8, comma, 0. Yeah, should get 0.2014. So approximately 20.1%. Okay, so if you're looking for this function, it's second, and you hit the distribute button, D-I-S-T-R, and then I go to A, so you have to scroll down a little bit, and you have to use PDF because we're only looking for 1. So this is 0.201, something like that. Okay, now the next one is, what's the probability that at least 2 frogs, at the least 2 frogs, so that would be from here up, right? So the probability of x greater than equal to 2, is going to be, the calculator, we would have to calculate these two. The calculator will not give you greater than, it just gives you sort of less than, the number plus less than. So it's going to have to be 1 minus the probability of x less than or equal to 1. Okay, so we'll just do 1 minus. So remember, all of these probabilities have to add up to 1. Okay, so this is just 1 minus binom, and we want to say CDF, okay, 12, 1/8, and 1. And I believe that's going to be 0.45, something like that. Let me, 0.453. Okay, so the difference is now we calculated these two. So that's accumulative. So that's why it's CDF. All right. So that the trick here is that I couldn't put in a 2 right there. I had to put in a 1 because it's going to give me, if I put in a 2, then I would have gotten this one, and that one. Okay. All right. Let me try to wrap this up. What's the probability of 3 or 4? So the probability that x is equal to 3 or x is equal to 4, well, they're independent. So that's the probability of x equal to 3 plus probability of x equal to 4. Okay, so nothing fancy. That's just going to be binom PDF of 12, 1, 8, comma 3 plus binom PDF 12, 1, 8, and 4. Okay, all we're doing is saying I want that number and add them together. Okay, so let's see. I can do that real quick. Sort of quick. You should be hopefully you're trying along with me here. So 12 comma 1 divided by 8 comma 3. So the first one is 0.12918 plus, one more time, I'm sure there was a way for me to do this all at once in the calculator, but I would have thought about it. So that's going to be 0.04153. So if I add them, I get 0.171. So approximately why did I write point? 17.1%. Okay? So it would be good to write out answers. Okay, so the last one is no more than. So let's think about this. No more than 4 frogs. So 4 counts. So it would be all of these. All right? So the probability of x less than or equal to 4, that's pretty easy to do. That's just binom CDF of 12 comma 1/8 and 4. The function just does it for you. Does the whole thing. So let's see, what is that? So just make sure I'm using CDF. So 12 comma 1 divided by 8 comma 4, and that's going to be 0.988. So approximately 98.9%. Okay, so almost 100%. That's interesting. So what's happening is there's sort of like a peak right in here somewhere around 3 or 4, and then after a while these taper off and become less likely. If you think about it, the mean is going to be 12. The mean, mu, is NP. So that's 12 times 1/8. So what is that? 12 over 8. So if we do a little factoring, 3 times 4 and 2 times 4. No, I didn't do that right. Did I? 3 times 4. That's the mean. Okay, so yeah, I see what I'm doing. 1.5. So the mean would be 1.5 frogs would have that trait. So right in here somewhere. Okay, so I hope that helps. You see that you do have to check the conditions. You should. It helps to build, this picture just helps me sort through the probability questions. Sometimes I can get confused when they say at least or more than or no greater than, all this language. And then the calculator gives a little twist too, because it doesn't give probabilities that are greater than, so you have to use the complement, and then you have to think through what number to put into the calculator. But after that, it's pretty straightforward. Okay? Good luck with these.